All right, so today we're skipping the whole, the hello world of Docker. We're going straight into the wiring closet.
Yeah, no basics.
Exactly. Our mission is to really distill what's happening behind the scenes.
Hmm.
The architecture, the networking, all of it.
Right, we're exploring the engine room, what actually happens when you run an application, and why this whole container thing is, well, so transformative.
Okay, let's start with that core concept, the client-server architecture. When I, as a developer, type a command like Docker run,
Mm,
that's all happening on the Docker client, right?
that's just the client. Think of it as the steering wheel.
The steering wheel and maybe the gas pedal. But what's the actual engine doing all the real work under the hood?
That engine is the Docker daemon, the Dockered process.
Docker, great.
Yeah, that's the core process running in the background. And it's responsible for all the heavy lifting, building images, running the containers themselves, managing networks, storage.
So the client just translates my simple command into the complex API calls the daemon understands. But the moment you bring in the daemon managing these containers, you also bring in this problem of ephemeral data.
Mm-hmm.
Containers are meant to be disposable, but data written inside them is just lost the second they stop.
Yeah.
So how do we solve that persistence problem?
Docker gives us a couple of really good tools here. For truly persistent data, the absolute gold standard is volumes.
Okay.
These are storage locations managed entirely by Docker, which makes them the best choice for anything critical, like database files. Makes backups and migration so much easier.
And the alternative, bind mounts, where you're just mapping a host directory right into the container, that feels a lot riskier for production data.
It is. It absolutely is. That's why we really only recommend bind mounts for development workflows.
So when you're iterating on code.
Exactly. If you're constantly changing your code locally, a bind mount lets the container see those changes instantly. It just accelerates that dev cycle. But yeah, for anything that needs to live long term, you use volumes.
And of course, most apps today aren't just one container. You might have a front end, a database, a cache.
All stacked.
And nobody wants to type 10 separate Docker run commands to spin that up. That's where Docker Compose comes in, I assume.
Compose is the configuration glue. It lets you define that entire multi-container setup, all the networks, all the volumes in one single YAML file. It takes the pain out of managing those complex local environments.
Okay, so our services are defined. Now they have to talk to each other. Networking is the next big hurdle. What's the difference between containers just talking on one machine versus, say, across data centers?
Well, for local communication, Docker makes that really easy with the bridge network.
The default setting.
Right. It basically lets containers running on the same machine talk to each other directly like they're on a small virtual LAN.
But the real power comes from scaling out, right?
Mhm.
Spreading containers across many different host machines. A bridge network won't cut it then.
Not at all. To connect containers across multiple hosts, you need a kind of virtual highway, and that's the overlay network.
And that's essential for orchestration tools.
Absolutely.
Yeah.
If you're using Docker Swarm or, more likely, Kubernetes, your application components are spread out everywhere for resilience. An overlay network is the only way they can communicate.
And all this complexity, it's worth it because of the raw speed. I mean, the comparison that always sticks with me is that containers start in seconds.
Seconds.
Because they share the host OS kernel.
Mhm.
Whereas a full virtual machine has to boot an entire OS and takes
minutes. It's a night and day difference. And that speed is what enables things like fast microservices and, those instant CI/CD pipelines everyone wants.
Speed is the benefit, but we have to talk security. What's a key best practice someone can apply immediately?
Easy one. Always use the leanest possible base images, something like Alpine. It just minimizes your attack surface. And, most importantly, do not run your containers as root.
Never is root.
It just limits the potential damage so much if a compromise does happen.
So, to recap, we've covered the architecture driving the commands, how to make sure your data actually sticks around with volumes, and how these containers talk to each other.
Right. And maybe for a final thought, while containers are amazing, once you scale up to dozens or hundreds of them, managing all that complex networking and storage becomes a huge challenge.
A management nightmare.
It really can be. Containers are powerful, but at that scale, they absolutely require orchestration tools. And that necessity is why the journey naturally pivots from Docker fundamentals to exploring the essential power of Kubernetes. That's the logical next step.